Howdy. Today we are going to cover a topic called risk pooling. You may also hear the same topic under inventory consolidation. Idea with the risk pooling is to combine multiple locations into a fewer number of locations. That way, reduce the amount used for the safety stock. Let's say I have two locations. Each of these locations has normally distributed demand with demand 1 and sigma 1, standard deviation 1, and demand 2 and sigma 2, right? I'm going to combine these two and create, let's say, a new warehouse. And at this new location, I will consolidate the inventory for this location. This is usually done in connection with the ABC analysis. When we do the ABC analysis, we may have, let's say, the D category of items. These are not very profitable. The sales quantities are low, and we cannot justify to keep them at every store or branches. If that is the case, then we would like to combine them so that we can have less number of inventory overall, and that will partially justify keeping the inventory in the system, right? When I combine this two location into a single one or consolidate the inventory into a single location, couple of things happens. One, I need to determine what's going to be the demand at this new location. Assuming that demand is independent between these two locations, location 1 and 2, when I combine the demand into a single location, demand is going to be just D1 plus D2, right? The next thing is the standard deviation itself. And if these are independent demands, again, there is no interaction between like locations. Let's say there is not a set of customers who would buy either from location 1 or 2. They are completely independent. In that case, we need to calculate the variance for both location and then take the square root of that number, right? Sigma 1 squared plus sigma 2 squared. And then I will take the square root of, so this new location will have the demand of D and standard deviation of sigma, right? Of course, I can have more than two locations, let's say N location with the demand N and sigma N, right? In that case, I can generalize this approach I just used here, saying that demand is equal to demand 1 plus demand 2 plus, right? Demand N. And my standard deviation is going to be equal to sigma 1 squared plus sigma 2 squared. And then I will add all the variances, right? Square means variance, and then take the square root of that number, right? And that way I can find again the new standard deviation and new average or expected demand. Now, there is a special case for this scenario where I could assume that demand at location 1 has the same parameters as the location 2, as the third, as the nth one, right? So what I mean is that demand is, not depend, demand is independent still and identically distributed. And identical, again, the demand 1 is equal to demand 2. Sometimes you will see IID, right? That's what it means. Again, I'm saying that demand 1 is equal to demand 2, and that is equal to demand N, right? And sigma 1 is going to be equal to sigma 2, and that's going to be equal to sigma N. If this is the case, I can simplify this formula here by saying that the demand at this new location after the consolidation is going to be N times demand 1, and standard deviation is going to be equal to square root sigma 1 times square root of N. Right? That is basically the risk pooling. We are going to have reduced safety stock and inventory in the system because as I reduce the number of location, or if I'm going from 1 to 2 and 3, I will have a reduction in the square root of that number rather than from, if I have 5 location, I'm not going to 20, from 20 to 4. It's going to be a little bit higher than that, but that means also I'm not proportionally increasing or decreasing. So I will have a higher customer service level for the same level or same number of inventory in the system. Now, we are going to solve a question. The details of the question is in the slide that I posted together with this notes or video. There are a couple of uh, information, or there's a list of information in that question. We have 5 warehouses, so n is equal to 5 warehouses, right? And then the lead time is 0.5 months, and I would say that is 2 weeks, assuming that 1 month is equal to 4 weeks, right? Inventory holding rate is 2% per month. Again, if I assume a month is 4 weeks, I can say that this is equal to 0.5% per week. The cost of each product is $75 per unit, right? Ordering cost or replenishment cost, which is A, fixed ordering cost, that is $50 per replenishment or order, right? And then the customer service level. In the question, it says the stock out probability is 0.15 or 15%. That means customer service level is 85%, right? And demand is given as 640 per week, and standard deviation is 60 units per week. Right? Given this information, the question also specifies that this company is using economic order quantity policy. That means we are using a continuous review based on the system, and it asks us to calculate the benefit of inventory consolidation. We are going to calculate this benefit in terms of 2 metrics. One, the cost reduction due to the consolidation. 2, inventory reduction due to the consolidation. Right. So as I said, there are 5 warehouses, and we are assuming that all these warehouses are identical and independent. That means if I do the math for one of them, it's going to be the exact same math for the other 4, right? With that, let's start with the analysis and say before consolidation, right? What does that mean? I have 5 warehouses. Each one of them is facing 640 units of demand per week on average, and their standard deviation and all the other information is here, right? And I'm going to do for one warehouse. Again, because they are identical, I don't need to do it 5 times. And that's the idea with the IID demand, because I can do the math for one, assume it is the same thing for other 4, and then compare with the after consolidation, right? That way, I don't need to do the same calculation for 4 more times at least, right? So let's start with the Q. That is 2AD I times C. Remember, I and D needs to be time consistent, and I have everything in weeks, so I'm going to just go ahead and use that. 2 times 50 times demand is 640 divided by 0.005, that is 0.5% per week, times 75, right? And if I take the square root of that number, that is approximately equal to 413 units, right? So whenever I order, I need to order 413 units, right? Second thing I'm going to calculate is safety stock. That is Z sigma square root of lead time. Z value for 0.85 is 1.04, right? And with that, I'm going to say SS is equal to 1.4 times 60 times square root of 2. And standard deviation is per week. So instead of using lead time saying zero point 0.5 months, I'm going to say 2 weeks. That way, week and week time consistent. And if I do the math here, the result is 88 units. Right, so we are going to keep 88 units as the safety stock. Right. Next, the R or ROP numbers, that is D times LT plus the safety stock. Right, and if I do the math, demand is 640 per week. I have 2 weeks of lead time and then 88. And that would be 1,368 units. Right. Right. While at it, let's calculate the AIL, average inventory level, and that would be Q divided by 2 plus safety stock, 413 divided by 2 plus 88. Okay, and that is, if I do the math correctly, 294.5 units. So on average, I have 294.5 units at the warehouse, one of the warehouses, right? And let's do the total cost as well. And I'm gonna go calculate the total cost per week, just because my demand and inventory holding rates are already in per weeks, right? Um, this is D over Q multiplied by A, then I times C, Q over 2 plus safety stock. Remember, this is the AIL I just calculated. So my total cost is going to be 640 divided by 413 times 50 plus 0.005 times 75 times 294.5. If I do the math correctly, total cost is going to be 187.92. Due to the rounding in the calculator, I may have a slightly different number if I use the exact values here. Let me try to do that. Okay. This is only for one warehouse. So only for one warehouse, I'm using an average inventory of 294.5 units with a weekly cost, gosh, of 180, $188, right? But in reality, I have 5 warehouses, right? My grand total AIL, right, total AIL is going to be 294.5 times 5, right? That would be 1472.5, right, units. And my grand total cost for these 5 places is gonna be 5 times 187.92, and that would be, again, if I'm rounding everything properly, 939.60 per week. Right. So that was only one fair house. Based on one fair house, I calculated the quantity, safety stock, reorder point, AIL, and total cost. Then I said, hey, these are all identical to each other. And that way I could calculate the total AIL and total or grand total cost for these 5 warehouses. That was before I consolidated. Okay. Now, after I consolidate, right, first the demand is going to change, right? We said n times d1, that is 5 times 640, right? At this new location where I consolidated the inventory for, that was kept at 5 different locations before, I'm going to see a demand of 3,200 per week, right? And my standard deviation is going to be, all right, just let's see if I can, gosh, n, right? This is n, sorry, right? And that would be 60 times square root of 5, and that is approximately, I did calculate earlier, let me find it, 134. 134 units per week, right? And with this now, I have basically a single warehouses that I consolidate the inventory into, and this warehouse has 3,200, or this location has per week demand with standard deviation of 134, right, per week. Right. I'm going to go ahead and calculate the same things. The Q, 2 times A is 50. Demand is 3,200 this time because I consolidated 005 and 75. That would be equal to 923 units. So for earlier, for each warehouse, I was ordering 413 whenever I order. With this consolidation, I'm going to order 923 whenever I order. Right. Next, the safety stock, and that is Z sigma square root of lead time. So Z was 1.04, right? Sigma is 134, and square root of 2. That would be equal to 197 units. Right? Reorder point, or R, right, or R, that is D times LT plus the safety stock, 3,200 at this new location times 2 plus 197, 64, 65, 97 units. And finally, I'll do the not SS, AIL, right? And Q over 2 plus SS, 923 divided by 2 plus 197. And if I can do the math, that is 658.5 units, right? Now, each of those smaller warehouses, they had basically 294.5 units on average, but altogether they had actually much more, right? 1,472.5 units of inventory. Now, after the consolidation, I just need to have 658.5 units of inventory on average, right? And finally, total cost is going to be D over Q, A times IC, Q over 2 plus safety stock. Again, this is AIL. I just calculated. My total cost is going to be, demand is 3,200 per week. Quantity is 923, 50 plus 0.005 times 75 times, right? All right. And this total cost is going to be equal to 420 point 29 dollars per week. Okay. So I know before and after cost. And if you remember, I said initially we were asked to calculate or quantify the benefit of consolidation. So I'm going to have before consolidation and after consolidation. And I'm going to look into two things. AIL, of course, the grand total AIL, not one warehouse before, but the total, and then the total cost. Total AIA before the consolidation was 1472.5. After I consolidated, it reduced to 658.5. Right? Before the consolidation, the total cost was 900, gosh, 900, somehow my pen is not writing, 939.60 per week. After the consolidation, it reduced to 429 per week. Right. So how would I quantify that the difference? I could say it reduced almost about $800 in terms of, I'm sorry, 800 units in terms of AIL. Total cost I can calculate AIL savings. Okay, as a percentages, I can calculate that is before consolidation, I had this many. After the consolidation, right, not that much, 58.5. And then if I ratio and multiply by 100, I can say, let me see how much is that saving. All right, this would be 814 divided by 1472.5 times 100. All right, and that would be about 55%. Right. Same way, I can look at the savings from the total cost perspective. That should be close to that number as well. Let me do this. This number is 55.28. So I don't want you to think it is gonna be the same number, 28%, right? For the total cost, same idea, 939.60 minus 420.29 divided by 939.60 multiplied by 100, right? And if I do the math, let me do the math, and all right, that is 55 27%, very close, but it is not the same. So by consolidating into a smaller number of locations, we were able to reduce our AIL, average inventory level in the system, and then also we saved in terms of money. Right now, when you have this much saving, of course, you can take all the 55% to yourself and offer the same customer service and everything. But usually, companies use some part of this inventory as an investment to the system. For example, instead of offering 85% after the consolidation, I can tell my customer, hey, we are consolidating this inventory. It may take an extra day to bring here, but then we will offer you 99% customer service level on this item, right? So let's look into that one. Let's say we are looking into an extreme case where AIL before and after are the same amount, right? So before the consolidation, it was 1472.5, and I'm saying like, hey, I'm going to keep the same amount of inventory in the system after the consolidation. What would be my new customer service, right? I cannot change the queue. Queue is going to be the same, order quantity. I can adjust the safety stock, right? I'll write the AIL formula for you guys here, right? What I do is I can not like I know the best queue, so that is not impacted with my customer service level, so I'm not gonna change it. The demand standard deviation is not gonna change. LT is not gonna change. Only thing is Z can change by adjusting the customer service level. And I'm saying that what if I keep the same AIL as before, right? What is the same AIL that I'm referring to? That is 1472.5. So I decided to consolidate and keep the same amount of inventory in the system after the consolidation, right? In that case, this equation must be equal to 1472.5. I know that Q is 923 after the consolidation. I don't know the Z value yet. 134 and then square root of 2 is equal to 1472.5. I can put this one on this side, right? And then I'll say Z times 134 square root of 2 is equal to, what would it be? Is it, right, let me do the math. 0.5 minus 11, right? And then if I divide both sides by, this is going to cancel each other, and I will end up with an Z value of 5.33, right? I checked the Z value for 5.33. It is not on our normal distribution table. It ends around 4, 3.99 or something. And at that point, the customer service level is like 0.9, 99%, 9999, a couple of nines. This would be an overkill. Practically, we have infinite inventory in the system, and we are going to offer 100% practically again customer service level. So what we do usually is that, again, we do not invest all the savings to the same item. I may increase the inventory on this item and maybe go to from 85% to 95%. That will still leave me with a lot of savings. And then I can invest those items or those remaining savings in A items, right? Remember, A items are highly profitable, high volume items. So if I can increase their inventory in the system, I'm gonna basically make more sales and be more profitable. The concept here, right, reducing the inventory in one item and investing in other inventories is called inventory redeployment. Right? So you are redeploying your resources. Right? With that, I'll stop here. I'll see you guys in the classroom. Bye.